Okay, so now we will start the assembly for your barrel cam. And before starting the assembly, please ensure that you have downloaded the standard parts associated with the lab 4 and 4B, and download that zipped folder into your directory for lab 4A and 4B. And after you have saved the zipped folder in there, simply you can extract files into this folder. So there is this folder. This is where there's 3 components that you will need for this assembly. So now I'm gonna simply start the process. To start, I'm simply gonna start a new assembly document. And the first component that I'm gonna bring it in after browsing, it will be the frame. So simply gonna drop it somewhere there, and I'm gonna change the units to mmgs, and I'm gonna save this file as in the same folder with the student ID. That's how you will save it, lab 4, and call it assembly, barrel cam assembly. I'm just simply gonna name it as lab 4 assembly. So now the next component, I'm gonna simply go to the assembly tab, and I'm gonna click on the insert components, and I'm gonna bring in the standard part from the and I'm simply gonna bring the slide rail. I'm gonna position it here. I'm gonna bring another component as well, so that I will start doing the mates all together. I'm gonna bring in the guide, and this is where I'm gonna basically start doing the assembly. I'm gonna position this one in this way, and I'm gonna rotate this one as well. I'm gonna assemble these 2 first, and then I will make the mating constraints with the frame. So the first thing first, what I'm gonna do is I'm gonna simply click on mate, and I'm gonna make this one and this one. I'm gonna make them parallel. I'm gonna click OK, and I'm gonna rotate this one a bit, and I'm gonna move this one a little bit on the side. And what I'm gonna do is next mate, I'm gonna select this face, and I'm gonna select this face, and I'm gonna add a distance mate for there, and I'm gonna leave it at 0.1 millimeters, and I'm gonna click OK. And now I'm gonna select, for example, this face, and I'm gonna select this face, and I'm gonna add a distance constraint again, and I'm gonna enter as 0.1, and I'm gonna click OK. So as so this one now slides on this rail. So now I'm gonna add relationship between this and this component. So the first mate that I'm gonna add is I'm gonna go to this one, and I'm gonna select this, and I'm gonna make them concentric. And the second one, I'm gonna select this one, and I just want to make sure that the whole count is correct. Let's try this. Yep, this would work. And I'm gonna make it concentric, and I'm gonna move this one up gonna select this face, and I'm gonna select this face, and that will be coincident. So that's done. So this can oops, I'm just gonna delete. I'm just wanna test this one out. Okay, so this is working fine the way it's supposed to be. And now I'm gonna bring in the next component and which is going to be, I'm going to bring the pusher, and I'm gonna bring it in, and I'm gonna rotate it around like that. All right, so now I'm gonna add some mates in here. I'm gonna click on mate icon, and I'm gonna select, for example, this whole surface, and I'm gonna select this hole, and I'm gonna make them concentric, and then I'm gonna select this one, and I'm just simply gonna go, before doing that, I'm just gonna move it up so that I can see it better. So I'm gonna select this hole and make them concentric, and then I'm gonna simply select this face and this face coincident, and this will line up things. So if I move this is how it's supposed to work. And the next component I'm gonna bring in is the pin. A sliding pin. I'm simply gonna drop it there, and I'm gonna add a mate. The first mate is between these two, and I'm gonna align it the other way, and I'm gonna click OK, and I'm gonna move this up. I'm gonna select this face, and I'm gonna select this face, and I'm gonna make it coincident. So this is done. So I'm gonna bring in the barrel cam now. I'm gonna click on insert components, and I'm gonna bring in the barrel cam. So the first mate I'm gonna add, I'm gonna click on mate, I'm gonna select this face, and I'm gonna select this face. And that's concentric. And now I'm gonna select this face, and I'm gonna select this face, and this one is going to be distance mate, and I'm gonna add 5 millimeters. Okay, so this one has some clearance. I could reduce the clearance by changing the size, but I'm just gonna leave it as is. I'm gonna see how the simulation is gonna work. Actually, my mate last one I have added, I have it in correct direction, so I'm gonna click on mates for the cam, and this distance mate, I'm gonna add it. I'm gonna flip the dimensions on that, because I don't want it to be going through. I need a little bit gap in there, and I'm gonna click OK to that. So that's how it's supposed to be. There needs to be some clearance there. I'm just gonna leave this pin as is. Okay, so I'm gonna bring the next component. Next component is simply actually I gotta go click on insert components, and I'm gonna bring in the standard component, which is the motor and gear. I'm simply gonna drop it in there. We are not making any real contacts between these. We're simply gonna line it up so it looks like a motor in the assembly. So I'm gonna select, gonna add a mate. I'm gonna select, for example, this hole and this hole, and I'm gonna make it concentric. And I'm gonna select this one and this one, and concentric, and now I'm gonna select this face and this face, and I'm gonna make it coincident. So this is where it is. Yeah, this pin I could move it by changing the constraint, but I will see in the simulation how it works out. And the last component for the assembly that's I need to bring in is the packages, which I wanna push them down. So now I'm gonna click on insert components, and I'm gonna bring the package. So for the package, we don't need the any mating relationships, but we need to position this package in this track so that it's positioned properly for the simulation. I'm simply going to save my assembly file because I haven't saved it for last 20 minutes or so. So this is in here, so I'm going to just simply show you how to position it. So I'm going to click on mate. You could manually move it around and then position it, but it takes a long time. But it's best to use this under mates. It's this checkbox. If you select it, it's used for positioning only. Any mates you add when this checkbox is selected, those mates will be removed as soon as you exit this mate dialog. So I will demonstrate that to you. So I'm simply going to select this face, I'm going to make it coincident. I'm going to select this face, and I'm simply going to select, for example, this edge. I'm going to make it coincident. So as you can see, this one, I'm going to select this face, and I'm going to select an edge or this face, and I'm going to make it coincident. So here is one package. We have placed it on this ramp now. So if I exit this mate dialog, and if I right click on it and I select copy with mates, and I do this, there's no mates associated with this package. So that's what I wanted to demonstrate. Another way to check is you right click on it and you look for the view mates. There is nothing there. Okay, so we need 4 more of these packages. So what I'm gonna do is simply select this component. I'm gonna press Control key and press C. It's Control C, and I'm gonna simply bring it on the graphics window. Control V once, Control V twice, Control V 3 times, and Control V 4 times, and all the components are in there that I am just copying. Okay, so the 4 are there. Now I'm gonna add the mates, temporary mates for positioning only, so that it lines it up. So for example, I'm gonna click on this. I'm gonna delete this first of all. What I'm gonna do is, because I'm gonna keep this box at this position, so I'm gonna select this, I'm gonna select this face, and I'm gonna make them coincident, but I need to check this box. I'm gonna click OK. So now what I'm gonna do is I'm gonna select this face, for example, and this face, and I'm gonna make it coincident. And I could select this edge, and I'm gonna select this one, and I'm gonna make it coincident. And I'm gonna select this face, and I'm gonna select this face, and in here I'm gonna add a distance mate. I want the package to drop with some gap. For example, I could just enter 1 millimeters, or let's go with 2 millimeters, for example. Okay, so I have a gap there, and now I'm gonna repeat the same process with the other packages. So between this face and this face, I'm gonna make it coincident, and this face and this face, I'm gonna make it coincident, and this edge and this edge, I'm gonna add a distance mate, 2 millimeters. click OK, and then now for the last one, selecting this face and selecting this face, coincident, and just gonna move it a little bit up. I'm gonna select this face and I'm gonna select this face. I'm gonna make them coincident and just gonna move it up a bit, and I'm gonna select this face and I'm gonna select this edge, for example, and I'm gonna add the distance made there, 2 millimeters. Again, I will emphasize this is only for the positioning. If you don't select this box, then your motion simulation won't work unless you suppress the mates. Alright, so I'm gonna click OK. So I'm gonna save this file in this configuration. So we are getting ready for the motion simulation. In the motion simulation, if you encounter any issues associated with this pen, you can resize it so it matches the slot, or you can reduce the this slot size, but it should work. But let's see, the only way to find out is by running the motion simulation. So in this motion simulation, what we're gonna do is we're gonna start with the regular process, clicking on SolidWorks add-ins, and make sure your SolidWorks motion package is tools are added in. You could also go under tools again, as you recall from the previous labs. You click on add-ins and you can bring it from there as well by checking the appropriate box. And to start the simulation, you click on the motion study, and in here, first thing first, what I'm gonna do is right click on this disable playback view keys. I'm gonna do that. Under here, select motion analysis. This is the most complete simulation that you can run in SolidWorks. If you need to calculate the dynamic forces, acceleration, and other things, this is the only way. The selection has to be at motion analysis, and there are some modeling elements which are not available in your animation or basic motion. Basic motion, you can run the kinematics but not the dynamics. There's some elements in here, for example these contacts, it's not available under basic motion. And with respect to results as well, there's a number of items you cannot extract with the basic animation or the basic motion. So now we're going to start modeling our simulation. To do that, the first thing first, we're going to add a motor. And to add the motor, I'm simply going to select this cam, and the speed we're going to specify is at constant speed at 100 RPM, and the direction does not matter. We can always change it if it causes any issues. So now there's a number of items in here which we don't really need. There is a number of components which don't move. So to reduce the time for the motion simulation, we're gonna fix them. So simply you could do it one by one by right clicking, and simply this one is already fixed. The frame is already fixed. We know this motor does not move, so we could fix that component. We know the rail doesn't move, so we could fix that as well. So I have fixed these three components. The rest will move and participate in the motion, so they will stay they will be set as float. So now under settings, I'm gonna change the motion analysis. Please change it to about 25 frames per second, and in the second one, to get the smoother motion simulation, we could increase this size. So we're gonna click OK. So the key properties, the simulation time, we want to set it as 5 seconds, and this you can slide in and out for how long you want to run the simulation for. And once you have done that, it's always a good practice to save before you solve for the motion. And if I run this, I'm just gonna quickly play. I'm gonna solve it, this motion. Let's see what it comes up with. As you can see, the barrel cam is rotating, but there is nothing else is happening. So in order to model the movement for this barrel cam, and so this slider moves in, we need to define the contact points. So I'm simply gonna position this one in a way so that this is right in there, and I'm gonna zoom in, and I'm gonna just make sure that this is positioned inside that slot. This would be our starting point. I'm gonna move this back there. Alright, so this is in the slot now. Now we're gonna define the contact points. So contact point is our first one is this one. What we're gonna do is we're gonna select this contact icon. We're gonna define the contact points, and we're gonna specify the groups. So one object is this, the second one is that. Okay, and we're gonna click OK. And the contact type, actually I'm gonna go back to just show you under this. I'm gonna go edit features. In here, the contact type needs to be defined. There's frictional parameters for and stiffness and so on and so forth with the damping. These parameters can be defined, but the contact between the two, we're gonna model it as steel greasy and steel greasy for both of them. And we're gonna click OK. So it brings in the frictional parameters from there. And now I'm gonna run this simulation again and again. Good idea to save and always rebuild and save. So if I solve it now, so you can see it is moving. The result is that it's moving the pusher. I'm gonna just let it finish. So with the motion simulation, to avoid the interferences and stuff, those parameters you can change the size of the pins and so on and so forth, and depending on what the results are for forces and those things, and that's where you can refine your design. So now if I play, so it's going through this package, but the package is not moving. So now what I'm gonna do is I'm gonna fix that. And to do that, we need to define the contacts between this pusher and these packages. So we're going to add another contact group, and this contact group, we're going to select this this pusher, and we're going to select all these packages. And let's see what the end result for that one is. I'm gonna click OK, and I'm gonna solve it again. So the simulation is done. Let's just play. So from the physics point of view, it doesn't make any sense. These boxes are flying all over the place, and also it's not what in real life this should work. So we need to fix our modeling a bit in here. So one thing that I'm going to do is I'm going to add the frame as a contact as well. In this group, I'm going to add, so I have packages, pusher. So what we're going to do is we're going to add frame as well in this contact group. And the contact type, we're going to simply do steel dry and nylon. Because the packages are made out of nylon, that's the reason I selected this material when we are doing the modeling. Now I'm gonna save this file. So now if we run the simulation, let's see, we calculate the motion parameters, and let's see if there's any change. So you can see this is slightly different than the results are slightly different than the previous motion results. So this is to do with the contact that I have just added for the frame. But still these boxes are flying all over the place. I'm just gonna wait for the calculations to end. And then I will define the gravity. So now so I'm just gonna play one so that you can quickly see it. So things are working fine with respect to the parameters that we have defined. Now the boxes are flying all over the place, so they should be going downwards for their weight, and that will only happen if we define the gravity. So to define the gravity, you're going to click on the gravity icon, and you can specify the gravity parameter. In the direction, you can simply select this edge, and you will see the direction of this gravity downwards on this side. So that's how the gravity is defined, okay, along this edge. So the value is fine, it's done, and now I'm gonna solve it again and see what happens with respect to the results. So as you can see, it's taking longer time to do the calculations because there is extra set of motion that it needs to resolve. So now you see the boxes are just falling downwards. That's how they should be falling under gravity. I'm gonna let it solve, and then I will change the parameter again. So now if I play this simulation, so you can see what's happening. So it kind of makes sense from the gravity perspective. However, if our design criteria for this system, for this mechanism, was that only one box needs to be pushed down the ramp at once. So our design does not meet that criteria, just from the functionality perspective. Now, this is the reason we do these motion studies, so we can determine whether the system would work at the design stage, or also we can refine our design to meet the requirements. So before we do the prototyping, it cuts down the design time quite a bit, and also it saves a lot of time in the product development itself. So now we're going to change our design so that there's only one box would be pushed down the ramp at once. Before I do that, I'm simply going to save this file, and I'm gonna copy this study as motion study 2. So if you want to go back and do the comparison, they could. And you could also do the next simulation with a different by saving the assembly and a different configuration, and you could set them there, and then you could run the second study on that. But that's not the requirement in your lab manual. So what I'm gonna do is I'm simply going to change the design now, and to do the making the change, we're gonna change the frame. And to do that, we're gonna right click on the frame, and you open part in its position. Okay, so once the part is open in its position, I'm gonna select this face, and I'm gonna look normal too, and I'm simply gonna add a sketch, and then to add a lip here, so that only one package will drop through at one at a time. So now I'm gonna click on sketch, and in here I'm simply going to no, I need a line. That's what I'm gonna do. I'm gonna go across there, come across, come down, line it up, and go across and do there. And I'm gonna do the same thing on the other side. Simply drawing these lines, and now I'm gonna add the dimensions. It's 25, 30, 15, 25, 30, and 15. So for example, this is the extra that's going to be added there. And now I'm going to click on features. I'm going to click on extruded boss, and I'm going to extrude it downwards by 355 millimeters. Wrong direction, so I'm going to switch it. So you can see it creates the slip around, so only it will allow one box at a time to slide out. I'm going to click OK. And this can be changed as well. You could change the ramp with the different things. Okay, so this is gonna be saved, and I'm gonna go back to the assembly, and I'm gonna update the assembly. So as you can see, things are the way we wanted them to be. And now we simply gonna go to the we're gonna save this assembly, and we're gonna go to motion study 2, and we're gonna simply calculate. So before calculating, I'm going to review the mates. There's still 12 redundancies, which I have not removed them, which I'm going to remove it now. How are we going to do it? We're going to go to this motion study properties by clicking on that icon, and we're going to specify replace redundant mates with the bushings, and I'm going to leave the frames per second as 25 frames per second. That's good enough for this simulation. And now I'm gonna simply calculate the simulation again, and it will simply take some time, and it's yeah, we'll just wait. So after this simulation is done, you could actually make the changes to the ramp if you want, just for to play around with it. So it's done. I'm simply gonna play the results. So as you can see, it is dropping one by one. There's many other things that you could change. You could change around other parameters if you wanna refine your design. One thing I would like to point out now is to just show you how to extract some good engineering results, because that's what is critical. Otherwise there's no point of doing these simulations, because based on those results you could further refine your design. So to do that, there's many things. It's basically with the motion analysis, it's solving equations of motions. So with all the parameters associated with the equations of motion, for example, forces, acceleration, position, displacement, and those things can be captured from the simulation. So extract some of the results. What I'm going to do is I'm simply going to change the transparency for this frame. That helps to select some of the things that I want to select. And I'm going to click on the results icon again. And in here, the first thing I'm going to do is I'm going to trace the trajectory for the package, how it moves along during the simulation. To do that, I'm going to select displacement, the velocity, and the acceleration. And from there, I am going to pick a trace path. And for tracing the path, for example, what I'm going to do is I'm going to select this vertex, and I want to select this corner for this package. Actually, it only can do it one at a time. So it has already traced this trajectory for this package, the top package, how it moves along. And I'm gonna click OK. The results, they are saved under this folder here. So any result that you wanna hide, suppress, hide plot, so you could simply hide or show your plots from there. I'm gonna leave it on for a minute, and I'm gonna add another trace. And for this trace, I'm gonna select for the trace path, I'm gonna select the opposite on this corner there. I'm gonna click OK. So now I can see both of them, and you see how it's making contact, how this vertex is moving along. So this is a useful information, and we know the box is flipping around. So if we want to make the change to our design, we could add some rollers there or some other mechanism so that the box travels smoothly. So this is good piece of information. So I'm gonna hide these plots for now. Hide plot, so that it's easier to visualize other parameters. So now what I'm gonna do is I'm gonna show you how to extract some of the other parameters associated with this study. For example, one interesting thing that you are interested in is the velocity profiles and the acceleration profiles for your mechanism. So now I'm gonna click on the results icon, and I'm gonna select displacement, and under here for example, I am going to have linear displacement, and I'm just gonna select the magnitude. And so under the results, I'm gonna select the magnitude, and under here I'm simply gonna specify this, and I'm gonna click OK. So this one basically displays the linear displacement, and this plot's been added under this results folder. The next one, I'm gonna click on the results again, and I'm gonna do slightly differently. I'm gonna select displacements, velocities, and I'm gonna select linear velocity, and I'm gonna click on magnitude, and I'm simply gonna select that, and I'm gonna click OK. So now it has plotted the velocity associated with the that package. Up to here, this is where it makes the last contact with the ramp, and then it just drops down in the space. So this is up to here is the reasonable data that if somebody wants to use it. And with respect to the next plot, what I'm gonna do is I'm gonna click and add the acceleration plot now. To do that, I'm gonna go to displacement again. I'm gonna select linear acceleration, and I'm gonna just look at the magnitude. I'm gonna select this face, and in here, if I select add to existing plot, then I could have more information just on one plot. I'm gonna select this, add to existing plot, and from here I'm gonna select plot 6, because this is the plot I will put the velocity and acceleration profiles together, and I'm gonna click OK. So you see it has added the acceleration associated with that package. So the first spike that you see when the first package moves out and it drops down, so these are the spikes associated with that, and this is the biggest spike which when it gets pushed over. So these results are extremely important. They could be used for your structural studies, and the loads associated with this motion study, they could be transferred over by to if you want to conduct other structural simulation studies associated with your mechanisms. One thing that we notice here, we don't really need the motion solution more than 3 seconds, so we could cut down the simulation time by simply changing the time key properties. So I'm simply going to close this for now, and I'm going to extract a few other results. For example, I am interested in to determine the contact forces. So I'm going to select, for example, forces. I'm going to select this contact force, and I'm going to look at the magnitude. I'm interested in the contact force between this and this face, for example, and I'm going to click OK. So this one basically provides the force that is a reaction force on that contact. So that's the spike, that's the time when the force is applied. So this force, we could use it for the simulation, for structural simulations. And now I'm going to add more contact forces, and I'm going to click on this icon again, forces. I'm going to select contact force, magnitude, and I'm going to select this one, and I'm going to select this one, and I'm going to click OK. So as you can see, there's two contacts that are happening. There's two forces which are the contacts are made, and this one is when it pushes it down, this one when this drops down, and there is some contact when this one retracts, the pusher is retracting. So I'm gonna move it back, and I'm gonna add a few more plots so that you can continue on adding other plots for your study. I'm gonna select the third package, and on this one I'm gonna add it to the existing plot, and I'm gonna use plot 8, so it's good for the comparison. Oh, I haven't specified anything in their forces. I'm gonna specify contact force, and I'm gonna specify the magnitude. And if I go select this one, show plot, so this is where I can do the comparison between the forces that it whenever it makes a contact. I'm gonna add a couple more plots to the same graph so that you can do a better comparison. I'm gonna click on results, forces, contact force, magnitude, this face, and add to existing plot. Okay, I'm gonna click again, forces, contact force, magnitude. Gonna select this, and the last one, plot 8. And I'm gonna add one more contact force plot. And for this one, I'm gonna select this. I'm just adding all the contacts between the packages and this pusher into plot 8. Alright, so it's been added, and to review it, I'm just gonna right click on it. I'm gonna show plot. So basically this plots everything in one plot, so you can see the differences between different components as the contact is made. So this is where the last contact is. So it shows you the magnitude difference. The spikes here are bigger because the boxes are dropping down all together, and that's why the forces are higher there. And as for the last one, it's the magnitude is the smallest because it's only one box is getting pushed down. So this information, if you wanted to protect your pusher and you wanted to have reasonable, only consistent force on it, you could change the design by there's a few things that can be done so that it only sees the same magnitude force for every single push. So these are the type of things that you should look into whenever you're planning to do the motion study. There has to be some purpose, and from this you could do much better job whenever you're designing your systems. You could also extract forces between the contacts to see how the pin is doing, so you could extract the data from there too. And that's where you can change the sizing of your sliding pin or the slot size to get better and smoother motion, because the smoother the motion, your machines and your mechanism will have longer life. So for the purpose of this lab, this is where this lab is done. So please make sure you save all the files, and please ensure to include everything that is associated with this lab when you're submitting your lab exercise work on Canvas. A few things I just want to point out is that you could change the plot settings in here. For example, by right clicking on it, you can change the axis properties and so on and so forth. And you could also change the curve properties by right clicking on it. You can change the design, the markers, and so on and so forth, whatever your preference is. Another useful function that the motion simulation offers, for example, you could copy the graph, this plot, and you could also export it and in the for a spreadsheet. I'm simply going to export it, and I'm going to open this file up so that you know what gets exported. So it takes the time, it takes the linear displacement, that was that graph, and I'm going to open this the force one. So it basically calculates, it exports out all the force data. And this can be useful. For example, if you're determining some position for your mechanism, you could export it out, and if you gotta program your motor or other parameters, you could use that information for the for your programming and so on and so forth. And I have that plot on my clipboard, which I had copied it. So you can just simply put it on the clipboard and you can bring it in your PowerPoint presentation and so on and so forth. So there are many other things available, useful tools which are really handy. So this is where I will stop this video. Thank you very much for watching this video, and I will see you for your next lab.